This is part 3 of chapter 10.1. Let's go ahead and finish up this section. We left off talking about alternative and null hypotheses, and that those are the heart of hypothesis testing, and that we're always testing to see um, um, how plausible the alternative hypothesis is under some given sample data that we have. You start with a null hypothesis and alternative, and then once you have that, we then have some possible outcomes that occur from a hypothesis test. The possible outcomes are you're either going to say reject the null hypothesis, reject the null hypothesis when the alternative hypothesis is true. This decision would be correct. There would also be another outcome: do not reject the null hypothesis when the hypothesis is true. This decision would be correct. So again, reject the null hypothesis statement when the alternative is true. That would be correct. The next thing would be to reject. We would reject the null hypothesis. Reject means to say it's not good when the null hypothesis actually is true. This decision would be incorrect. This type of error is called a type 1 error. And then another situation would occur would be to do not reject the null hypothesis when the alternative is actually true. So you're saying the alternative hypothesis is probably true. However, the alternative is true. So this decision would be incorrect. This type of error is called a type 2 error. So we're going to go ahead and look at those outcomes and those errors, because errors become important. So going back to that medical pharmaceutical company example, 2%, the researcher conducts a hypothesis test. H0 is p equals 0.02. H1 is p is greater than 0.02, which we had done already over here. Explain what it means to make a type 1 error, and explain what it would mean to make a type 2 error. Let's see if we have some space in here. So part A, type 1 error. Let's see if we can leave some space there. Type 1 error is to reject the null hypothesis when the null hypothesis is true. So in this case, what does it mean to make a type 1 error? What's going to happen is we say, so a type 1 error in this case is us. We say that the proportion of percent is not 2%, but in fact it is 2%. So we reject this statement when in fact it is actually true. That's a type 1 error. A type 2 error, that would be part B. Let me see if we get in there. Type 2 error is to not so the type 2 error is say that the proportion is 2%. The proportion is 2%. The proportion is 2% when in fact the proportion is not 2%. And so that would be a type 2 error. We said the proportion is 2% when in fact that it's not. Type 1 is to say the proportion is not 2%, but in fact it is 2%. That's a type 1. So those are errors we're going to be looking out for when we conduct our hypothesis tests. There are some symbols we use to denote these types of things. So what symbols do we use to denote the probability of making a type 1 error and the probability of making a type 2 error? Some of the symbols for type 1 error, the symbol is alpha. It's the alpha value. And for type 2 error, the symbol is going to be beta. And again, this is alpha. And then we say this as beta. And those values give us the probability of a type 1 or type 2 error. Those would be the symbols that we would be looking at. And so the probability of making a type 1 error alpha is chosen by the researcher before the sample data is collected. And then the probability of a type 2 error, beta, is the probability of making a, sorry, let's finish this up. And so we've used this term before, but we revisit it here. The level of significance, and we use that for confidence intervals and for confidence intervals. The level of significance, alpha, is the probability of making a type 1 error. There's a kind of a cool graphic here that you want to be able to reproduce so that you understand that. And so what's going to happen is our 4 outcomes are put into a table. And so if your null hypothesis is true and you do not reject, that's a correct conclusion. If the null hypothesis is correct and you reject it, that's a type 1 error. If your alternative is true and you do not reject the null hypothesis, that's a type 2 error. If the alternative is true and you reject the null hypothesis, that's a correct conclusion. We'll have to practice that, but you want to make sure you can reproduce that table to understand type 1, type 2 errors. In other words, the probability of a type 1 error increases, the probability of type 2 error decreases, and vice versa. So if you want to reduce the error of one, you increase the error of another. Something we think about with hypothesis testing is it's similar to going to a court case in a jury, in that a jury makes a decision of guilty or not guilty, and that's equivalent to our reject and do not reject. And the jury can be wrong with the verdict, right? The defendant could be guilty, and then the jury says guilty. That's a correct decision. Or the defendant can be innocent or not guilty, and then they can say that, but he could also, or the defendant could be guilty, but then they say not guilty, which would be incorrect. So keep it in mind. I'll use that analogy of hypothesis testing in court, in like a court case. And to finish off hypothesis testing, we make a conclusion in the end. And it's important to recognize that we never accept the null hypothesis. We only use the word reject or do not reject. We don't know if the null hypothesis is true for sure. We just say we have enough evidence to not reject. Sample evidence can never prove the null hypothesis to be true. But not rejecting the null hypothesis, we are saying that the evidence indicates that the null hypothesis could be true, and that the sample evidence is consistent with that statement in the null hypothesis. When we write our conclusions, the conclusions, very important, highlight, remember, the conclusion to a hypothesis test is always as follows. There is or is not sufficient evidence to conclude, insert the statement in the alternative hypothesis. So we're always making that statement. We always include the alternative hypothesis in our concluding statement. There is or is not sufficient evidence to conclude that the alternative hypothesis, blah, blah, blah. So let's take a look at what we mean by that. And so to finish this off, the medical pharmaceutical company has just developed a new antibiotic. 2% of children taking the antibiotics experience headache. The researcher for the Food and Drug Administration believes that the proportion of children taking the new antibiotic who experience a headache is more than 2%. So the null hypothesis is P is equal to 0.02. The alternative is P is greater than 0.02, and that was from here. Is more than, that's the alternative. So there's assumption that it's just 2%, and then the researcher thinks that there's more than 2%. Suppose the sample evidence indicates the null hypothesis is rejected. So what statement would we write here? You collect data, and then you have enough data to say the null hypothesis is rejected. We are then going to say, we can say this. Let me make sure we can squeeze it in. What we're going to say is, since we reject the null hypothesis, H0, there is sufficient. I'm using the is because my statement is with the alternative and we just rejected the null hypothesis. There is sufficient evidence to conclude that, insert statement, to conclude that the proportion of what? The proportion of side effects is more than 2%. That would be our statement. If the sample evidence indicates that the null hypothesis should be rejected, since we reject the null hypothesis, there's sufficient evidence to conclude that the proportion of side effects is more than 2%. Let's say another example. Suppose the sample evidence indicates the null hypothesis is not rejected. State your conclusion. So we're not rejecting. And so to finish this statement here, since we do not reject H0, we say there is not sufficient evidence to support. Since we do not reject the null hypothesis, we're not rejecting that. We're pretty much rejecting that. There is not sufficient evidence to support the claim that P is greater than 0.02. That would be our conclusion. The concluding is always there is or is not sufficient evidence to conclude that P, the alternative, is what it says it is. And so that's it. Make sure you read this caution here. We never accept the null hypothesis, but without having access to the entire population, we don't know the value of the parameter exactly. Rather, we say we do not reject the null hypothesis. Again, it's just like a court system. That's it.